Cool. Thanks, Abhishek. First of all, I'll start with requesting everyone to turn on their videos so that the interaction is even more fruitful. Thanks guys. Thanks for tuning in on a good Saturday evening for the ADG meetup. So let me introduce what is ADG and what we do here. So ADG started back in 2018. Our first meetup was held at Grover's headquarters. We started with 15 odd people. Then subsequently we went to various and the mission was to create a community which was lacking in Delhi, specifically targeting the Android community, which was lacking. And then we started with Grofers, and then subsequently went to Zomato, EPS Mall, Oyo, Urban Claps, Tokopedia, and Expedia, and some offbeat events also. Currently, we have a Slack group, and our overall member size is more than 2,200 members strong. And at Slack, we have very active 190 plus Android developers who try to discuss a lot about whatever happens in Android on a very frequent basis. Sorry. And we are present. What we do is whenever we record our talk, whenever we have held a talk, we do share it with the world so that people can go through it later. So we have our YouTube channel. We are very active on Twitter. Thanks to Abhishek, we try to share whatever the content that we produce or whatever good content is produced around the world related to Android. And Facebook, I would not say we are very big fan of Facebook here. I'll be honest, but yes, we do have a social responsibility, and we are present there. Cool. The objectives, Abhishek is with us. Abhishek, would you like to take care of objectives?
Yeah, sure. So, like the primary objective was to build an active community of Android developers specifically, and in Delhi NCR specifically, because we when we started with the group, this was lacking. Like there was no community which was very active and regularly meeting at that point of time. So that was the primary objective. And of course, like what we want, this is an open group, and all our events are always free for everyone. And we are also upload our content to GitHub and YouTube afterwards. So secondary objective is also to like accelerate personal growth and learning by collaboration and knowledge sharing. So after meetups, we also do networking sessions, so that you can talk to your peers who might be working on the same problems as you are, so you can learn from them, and obviously you can also uh, teach them. Then third was to like provide opportunities for everyone. So opportunities can be related to recruiting, or opportunities can be related uh, to other jobs, etc. So when people meet, that provides opportunity to everyone. Yeah.
Correct. And we have a small team which tries to take care of these events with me and Abhishek taking care of the organizing part. Then we have, as we said, we are very active on Facebook and Twitter. So we have a community which people who help us with that. So Ashish takes care of everything that we record in our offline world. Similarly, Shaba, who also takes care of our Twitter handle. And we also a lot of our speakers and hosts, which we try to give people a chance not only to speak, and there are various first time speakers also on a ADG platform, and there are various first time hosts on the ADG platform.
We are also always looking for new speakers. If you want to speak on something, if you have a topic that you want to share with everyone, then you can always reach out to us. Yeah.
Cool. I guess that is about us. So you can use this time, and if you like any the content that we have, I'll introduce the speaker soon. You can take a screenshot and share on Twitter with the hashtag ADG-Delhi. So with that, I'll try to introduce our speaker today. who is Akash. Akash is a fellow colleague of mine at Urban Company. Akash started his journey, I guess, back into around 18 or 19 only when he passed out from college, if I'm not uh, wrong. And he started with web development. And his passion led to him deep diving into Android by chance. He was very fan of Android when we started. He was not able to take a grasp of what this technology is and how do you build UI from coming from a web background. And from that, he went deep into developing mobile apps. And currently, he is one of part of our central platform mobile team at Urban Company. So Akash, over to you now.
Thank you. Let me share my screen first. Right. So is my screen visible?
Yes.
Yeah, visible.
So hi, Akash. I'm an SD2 at Urban Company, and I'm part of the team building front-end platform at UC. Today's talk will be about building world-class apps with React Native, which would be mostly we'll discuss around what is React Native. We'll take a peek in its architecture and see how it works. After that, we'll be seeing how it is able to perform seamlessly on cross-platform applications. Then we'll discuss what does it actually mean to be world-class, what we expect for a top-notch app to be, and then we'll see how we are actually using React Native to power our applications at Urban Company. And after that, we'll have a short Q&A. So let's get started. So first, what is React Native? It's a buzzing word in the tech industry. You must have heard about it. Some of you might have even worked on it. But in simple words, React Native is something that enables you to build applications with JavaScript and React, targeting multiple platforms by using native UI building blocks. Here, focus on the word native. A lot of people have a misconception that React Native helps you build hybrid apps, which is not the case. It uses native functionalities and just a layer on top of it to control that native functionalities. So let's try to understand the motivation behind it and how it came into existence. So first, let's talk about React, what it actually does. So back in 2013, when React came in around 2011. And in 2013, Facebook noticed how much they have achieved using React. So uh, they have actually built something that forces the users to break down their application into discrete components, which makes it easier to iterate on products because every part is now functional and broken down into smaller units, which can be iterated easily. Uh, it wraps the underlying implementation of the browser's imperative API and with a declarative one, which raises the level of abstraction and it simplifies the programming model in which you have to build. It also makes the code more predictable and application more reliable because we understand what goes on inside the structure without having without the need to have a look at overall everything about the code. We can just focus simply on the parts that we are building. And in the long run, it makes it easier to scale the code as well as the size of teams which are building on it. Uh, Apart from these advantages, it is also built upon JavaScript and which has a very huge community. This enables a lot of open source frameworks to be built upon it, like React has Redux and Relay and several other open source frameworks. And of course, there's advantage of the JavaScript language that is powering it. JavaScript is fast to iterate on because it's simple, it's flexible, it's versatile, but it's only for web. So everybody understands the importance of native here. It offers a rich and performant set of UI components. It has multiple threads available to do more parallel work, and it provides a seamless user experience, so it cannot be ignored. So, but there are some issues with native development. As we are Android developers, and most companies have Android and iOS apps. Uh, to build a feature, we generally have to ship it on these three platforms: Android, iOS, and web, for most companies. And if you're a scale, uh, you always have three apps. So to build a feature, you have these three apps, and then you also, of course, need a backend developer. So technically speaking, you need to have a team of at least 4 people from each of these horizontal teams to be able to execute a feature. Because if maybe there's some less bandwidth on Android or iOS, there would be parity. That some kind of feature is available on Android but not on iOS, which is not the place a company at scale would want to be, right? So, but there are some issues with it. Uh, it is slow to iterate on because web is easily deployable, backend is deployable, but Android needs to be compiled and uploaded to Play Store, and we have to wait for the user to willingly download it. Similarly for iOS also has a longer uh, Apple review time because the Apple team reviews every piece of code that goes on production. So this is we need 4 teams to build the feature, and it's slow to iterate on, uh, slow iteration and adoption. And the sad part is even for bug fixes. So if you ship something which is breaking on production, you have to wait for a week, maybe. You can pause the release, but you might have to wait on the goodwill of nature that maybe users update their app. Uh, so there is an issue there. Except that there's also development challenges because layouting is not so simple. Um, there have been developments in the past few years. Like constraint layout is very powerful, but it also comes with its own performance issues because it's not very flat as such. Similarly, you have to recompile after every small change that is a major pain point if you have worked on a Android app, right? So let's see what Facebook did actually. Facebook actually thought that let's somehow get this JavaScript and React code that they have achieved so much success on. Let's get it, and let's try to do it natively. So one of the ways that could have been done was using web views. Android, iOS natively support web views, and uh, that would have been a viable option, but it's not as performant, or it does not give a native feel to the user. And that's so it's not the final solution that you would have. There's another option that you could actually build React on native, powered completely on Android and iOS. So Facebook actually went that way. They created component kit for iOS, but that also poses a challenge that for every platform they would might have to build a new library from scratch, and only Facebook developers would have context over the React API and how it's supposed to work. And then iteration over React would be a lot challenging because you have to update all platforms one by one. So there's a challenge. So what they did was, let's say there is a native layer where you have a lot of native capabilities like components, Wi-Fi, camera, Bluetooth, these things like that. Uh, what they did was this mostly runs on the UI thread. Like the rendering part runs on the UI thread, but there's also multi-threading capabilities that you can run things in the background or in parallel threads. You can do parallel work. So what they did was they took the React code, they put it in a bundle using a Metro bundler, and they ran a JavaScript thread, which is the React native layer. To run this thread, they had a JavaScript engine, which is JSC, that is available on Android and iOS by default. It's already there. So you use that engine and you run it on a thread. You put your React code in a bundle and you run it on this thread. And you are basically running a JavaScript code on your native app. But how would you then communicate with the UI thread? So for that, they created a bridge. This bridge was supposed to work like this, that they JavaScript is able to invoke native functionalities, native functions using this bridge, JavaScript would send a JSON, something like, I want to call this function name from this module, and this is the payload for that. And the native thread, the native layer, would interpret that using most likely a React Native SDK, which would understand that JSON and actually invoke that functionality. So this is what they did, and they actually got this to work. And this is how it actually works for React Native. This is the basic architecture. JS thread knows about all the JSX elements that you write in React, and at the bottom of these elements are some native components. As I said before, this is native building blocks. It's not hybrid app. Facebook has built this everything on this using native frameworks. So let's say at the bottom of any kind of view, you would have atomic image views or text views or views, just a view to wrap anything. So what they did was their React Native SDK has these views implemented in Android, and they expose it to the React Native thread using a bridge. So let's see how they would do that and how we can do that for our custom views as well. So there's something like this. Don't go too much into the code. But this is for the native functionalities that we want to achieve. Let's say there's a location module. We want to fetch the user's location, or we may be saving their addresses in our DB locally. So to get that, on the left side, you'd see the React code that's actually working. You import native modules from React Native, and from that you can get a location module if it's exposed from native. You implement some functions that you can use on the React Native thread, and you can just call it, just calling it like that. Internally, the React Native SDK would convert this into a JSON, and it would this command would be executed natively because native understands it. So its implementation on Android would be something like this on the right, that you implement a class location module, and it's extending React context based Java module, which is imported from React. So the React SDK gives something like some interfaces that you need to implement to get your functionalities exposed to React Native thread, to the JS thread. So you basically just have to give a name to a module, and you have to annotate it with React method. And you can write any kind of native logic here. You can maybe even pass its data to a parallel thread, and you can do anything basically. So this is how it works. You then wrap this module, and when you are initializing React, you pass it to them. So this is Android. Similarly, there's for iOS. The similar structure is there. You at the end you'll see an interface where you expose this. You expose your native module using this interface, and it just works. Similarly, for our custom views, we have, let's say, an image view. Let's call it my image view. So on the left, you see the React code. How would you use a native component? So you have a normal React component welcome screen where you have a view, and inside that you have text. So view and text, these are atomic components that React Native already gives you. They have implemented it already, and you can use it as you please in any kind of layouting structure. Then let's say you have a custom image view. You can use that using this require native component from React Native. Here you just give your name, that this is the way name in which my custom view exists, and you can give it some properties that it's expecting. On the right, you see the Android code for this. So let's say my image view was a custom component that I built over Glide or something, or Picasso or anything. I've exposed it using a get name, exposed it using a simple view manager, and it has a get name my image view, which is actually used by the React Native thread to understand which component is this pointing to. You have a create view instance method. In this, this is called whenever your view is supposed to be mounted by the React thread. And for any kind of properties that you expect this to get over at runtime or maybe on re-renders, uh, you expose it as a function and you say @react prop and the name of the property. So on the left, you see that there's a source image URL. So let's say it's a string. On the right, you see that you get it here. And you can just pass it on to a custom view uh, and it works. Similarly, you can do this on iOS. There's a native custom my image view and you expose it with an interface as we see for native functionalities to native modules. This is the basic code that we generally like, but you don't really have to do this because, as we said, JavaScript and React community is huge, and there's a lot of open source contributors who are ready and they have been building on libraries like these. So most likely you might not need it, but you can build it if you want. Now, as you saw, you can write native functionalities and views and expose them to React Native. But what about layouting? Like we passed height and width, but how does React actually render it to the view? How would React know which comes first, which comes down? So it's all done using CSS. CSS is a popular framework for web where you style your widgets simply like any Android or iOS. You have margins and paddings. But for layouting, it supports something called Flexbox. Flexbox is a property loved by web developers all across. It is something like constraint layout and constraint layouts flow property. And similarly, I think there are things similar to this in iOS as well. But it basically allows you to expand or divide your views and into grids, any kind of property expanding and layouting. That happens with Flex. But to do this, what Facebook did was they created a layouting engine called Yoga, which is a cross-platform layout engine written in C++ to support Flexbox. This layouting engine is cool, but it doesn't exactly render things since all rendering is restricted to UI thread on Android. So it talks to the UI thread back and forth using this small communication layer. Yoga is written in completely C++, so it's using JNI. The Android can directly talk to it, and React Native SDK does this part for you. So this is what happens in generally in React Native, but you might see a lot of problems here, like this bundle must be shipped with the app. You can send it over the OTA, but React Native does not provide this as a capability out of the box, but you can build over it. You also see that this bridge is just one bridge. So it's obviously a possibility of a bottleneck, because if you send a lot of JSONs to the bridge, it might choke the bridge because the memory is limited. Your apps can be low end as well. So there's that limit. And this JSON that's passed through the bridge is always asynchronously and batched. So there's no control on the order or when and where when the data would be coming. It's all asynchronous. Then there's an issue that native modules need to be initialized at startup. Whenever you are starting the React SDK, you need to initialize them because they need to be available for React to invoke anytime. So that's also an issue. And lastly, JS does not give you control over Yoga directly. So as we just saw, Yoga helps you in layouting using Flexbox. So how it actually works is JavaScripts give you what to render. Native React SDK knows what to render, and the UI thread constantly talks to a Yoga thread to understand how to position the elements, when to layout and re-layout, and how to actually do that. So this is also an issue. And as developers, as React Native or native developers, what can we do about this? Since it's all single threaded, since JavaScript is single threaded, we should not do any kind of expensive operation on that thread. Any heavy lifting can be done natively. Let's say I have a timer or I have a video player like heavy views. I don't really need to implement it on the JS thread. I can simply write a custom view natively and expose it and use it as well. The community also noticed problems with animations because these days we have 60 hertz and 90 hertz phones. But if your app doesn't run at 60 FPS, if there are any kind of frame drops, they are noticeable to the users. So to solve for that, since the bridge is a bottleneck, and if all kind of animation updates, what to update on each second goes to that bridge, there's always a possibility of a bottleneck. So to solve for that, there's a community. There's a company called Swanson which came up with Reanimated. So Reanimated is a framework they built which actually runs another JS thread just for animations, and it supports that you annotate your methods with uh, some declarations so that they know that this is supposed to run on a different thread, and so they achieve actually 60 FPS with that. So those are some things, but obviously the Facebook community, the Facebook developers also know that this is a problem, and this is how they're planning to solve it. They actually rethought the whole architecture, and this is what it looks like now. Instead of the bridge, they introduced GSI, a JavaScript interface. Uh, what this does is JavaScript interface is completely written in C++, and it's directly invocable from the JS thread. It's directly invocable from the native thread, and it solves all the communication without a bridge. Without a bridge, because this is all compiled. Uh, the JS thread can now invoke a native functionality just as it would invoke any other function. It does not need to serialize and deserialize a JSON and pass it through a bridge to actually get that. So JSI has this native module, which is directly talking, which is just the native functions. And how it does is that they're introducing a code gen. When you compile your app, it would automatically convert all your native modules that you build using their interfaces to C++ code, to the JNI. And they would, using that, you can, JavaScript can directly invoke them. They use your function declarations as interfaces, and JavaScript would, if you're using Flow or TypeScript on JavaScript thread, you will also get types there, that this function expects these kind of parameters. So this is something really interesting that they're trying to do. And the second part of JSI is renderer. So if we remember, Yoga, to interact with Yoga, there was no option for JavaScript to do that. JavaScript used to talk to the UI and UI would talk to Yoga back and forth. This is also solved now using JSI because Yoga is C++ and JSI is C++. JavaScript can now directly talk to Yoga as well, and native can also directly talk to Yoga. So this solves a lot of performance bottlenecks across rendering, across bridging, but it's still in development actually. They have been working on it since the last 2 years, and this year they're releasing the 0.68 version of React Native, which will have this functionality exposed to as a simple Boolean flag. You just set it to true and everything now works on the new fabric render, which is they call it now. So that's how easy they make it for the developers to adopt to the new changes. So the new React that they're installing here supports concurrent mode, which basically allows you to prioritize your state updates. You can say that if the user is crawling, I want to give priority to the bot element that they're going to. We have opt-in synchronous execution because now it's not a bridge. You can do it directly. We have shared ownership of the C++ shadow tree, which is Yoga, because now JavaScript and native both can interact with. So far we have discussed what is React Native and how it works. Any questions so far? Let me check the chat. Avinash asks, both React and React Native code are working code, or we need to code React and React Native. Uh, React and React Native are not much different actually. If you know React, going to React Native is nothing new. There's a very small learning curve, which is what to import from React Native and nothing else. All kinds of CSS layouting, all kind of styling, all kinds of components that you build are directly available for React Native. Arnav asked, apart from exposing native modules, basic native text and image views are also exposed to React Native too, right? Basically, text components in React Native must be mapped to text view in Android and similar for iOS. This too is communicable based. So yes, uh, this is actually what they do. Just like you would expose any custom view, the React Native SDK ships with text views and the view. That view is actually a view group which you can wrap around any other components and it positions them. And just like how we did for set source, they have exposed all kinds of uh, properties that are available on views, and they are shipping it out of the box. But yes, it happens over the bridge, and so far, and their new architecture would obviously be much more performant since so many callbacks and choking can be avoided now. Cool.
Any other questions till now in terms of React Native's architecture and anything specific? Feel free to add them in chat. We'll take it forward in the Q&A part. Kash, you can get it forward.
Cool. So, uh, so far we have talked about these things on how React Native works and it's about its architecture. And when you say cross-platform, it doesn't only mean Android or iOS or anything. Since the JS community is huge, very huge, uh, there are so many React developers out there and so many open source contributors. They've taken it upon themselves to build and serve it on new platforms. So in the architecture, we saw that there was a native layer and there are native capabilities that could be exposed. To implement it for a new platform, you just have to uh, create a small SDK from React Native, which is able to understand the React Native part, the JS code, run it on a thread, and it's able to use the bundle. And it just needs to invoke the native functionality with the right interface. So there are a lot of things that have been done. There's Android and iOS apps that we can build with React Native. There's desktop apps that we can build with React Native. Microsoft has actually built it. For web also, there's an open source contributors who have built React Native Web, which runs the same code on web. Uh, Last year, Microsoft announced that the latest Xbox that they're shipping is actually the all of the core UI, all the menu screens, everything is built using React Native. And a few people actually built VR with React Native. So that's all possible because you just need to uh, change that native part and hook in your own platform. So that's how they do the cross-platform stuff. Now let's move on to the second part of this session, which is world-class apps. How would you build a world-class app? So before that, let's just define what we mean by a world-class, what we expect a world-class app to be. Um, so for for the app to be world-class, we expect a delightful user experience. By world-class, I mean apps which are served to at scale to a lot of users and across the world in all kinds of devices. So users must feel delighted while using the app, or why would they stick to the app? App should be performant, and there should not be any frame drops or any kinds of uh, bugginess or lagginess on your screen. App should be consistent and reliable. Uh, they should perform what all the features they say. Uh, and if your app is implementing a feature, it should be available on all the platforms you're serving. Let's say if you have a Android and web, so if you build a feature on Android, it should always be available on web as well, because that's what the users would expect, and it should be reliable. Um, it should not break in case of any kind of faults for the user. There should be some kinds of self-healing um uh, fallbacks, such that the user's experience don't break even when there's an issue on the company's side. And obviously for the developers, it should be easy to build and iterate on. uh, as we grow, as many startups are coming up, we need to ship our features as fast as possible to the users, so that we can perform ABs and generate the data, uh, read through the metrics and see which kind of thing works for the user, which they prefer and which they don't. To get that done, it needs to be easy to build on and easy to iterate on. So let's talk about how we do this on at Urban Company. Meet Uran. So we all talked about this all React Native architecture. What we did was uh, we just call it a native layer, uh, and React Native is a part of it. We built Orion Android, Orion iOS, and Orion Web SDKs over it, which basically wraps all the features, all the capabilities that a native platform is supposed to serve, all the building blocks that a native has to work on. Since React Native is not something that is exclusive, you can hook any existing Android app or iOS app with a new React Native screen without affecting the old screens. Uh, that's what Orion Android or Orion iOS, these SDKs help you with. We have our existing Android iOS apps. We just integrated these SDKs, and now the new screens are some screens are working on natively, some screens are working with React Native. So what these SDKs do is they expose these native modules, they expose the native UIs, native views, and to the React Native layer, and they talk to React Native. Then we built a platform layer on top of it. This exposes all the bridges. It has a lot of interfaces, which does the state management for you, which does the bundle management and OTAs for you, which has layout builders to build the layouts for you. It has automatic exception handling and logging uh, to Crashlytics and for you. And we have a VDL, which is basically a visual design library. Has a lot of theme components which our designers sat on and thought of. And for all the heavy UIs, we have native components, which are also part of this VDL. And on top of this, we have the business layer. So to build a feature, we are now calling it micro frontends. Micro frontends are simple, plain JavaScript code that you write, and to build your pages, you just implement those interfaces uh, that we expose from this platform layer, and that's how we build a screen. And all these interactions are plainly done on the micro frontend level. And now the feature teams, the people who need to build that functionality, they just need to know about this business layer and how to create the pages. All that React Native part, the Android part, the iOS part, the web part, everything is abstracted out. You know which components exist because you have the designs, and you just need to send the proper payload from backend, and it just all works. So that's what we did with at Urban Company. Our Orion framework is powering a lot of our screens, and this is what we do. It helps you build Android, iOS, and web app using plain JS. You can write any kind of front-end logic, and you don't need any expertise on front-end. So as we talked about before, Earlier, to build a feature, we need to have four people from four different horizontal teams. A feature would be owned by a backend dev because he has the most context. But generally, you would also have a Android, iOS, and web developer to implement this on the native platforms. Now, a backend developer, since it's plain JS and no kind of expertise is required, one single backend developer can implement a feature end to end on all the platforms. This also helps in debugging any kinds of issues with the flow. Uh, if there's a crash, we know that it's coming from the micro frontend layer. There's isolation of errors to just one part. Uh, then we also reduce the development time and effort by 60%. This we have noticed since the past year that since all code works on the same platform, there's no duplication, no distributed ownership, and we don't need to implement the same thing three times on Android and iOS and web. You just need to implement it once. Uh, we also have the option to uh, increase our adoption rate by over the air updates. So about that bundle we talked about in the architecture, we can actually ship that and download it in a session in a user session, and on runtime we can just replace the older bundle with a new bundle that we downloaded, and you now can support a new feature out of the box. No need to wait for development releases. This is majorly useful when you need to solve a production issue, a critical bug. uh, Earlier for Android, as we know, we had to first halt the release, we had to ship a new hotfix release and try to get it to 100% as soon as possible. And then we were in the hands of your users that if they willingly go and download the app, or if their OS actually updates the apps for them, then only they get the fixes. But now with over-the-air updates, we are doing it in the background. When user starts a session, in the background, it tries to check if there's a new version available, and it downloads it and updates it. Uh, this is the new customer journey flow that we implemented. On the left side, it's web, and right side is iOS. Right side, it's Android. iOS looks exactly the same, and as you see, the same kind of look and feel, the same kind of experience is powering the same apps uh, all over all the platforms. All the business logic is powered with one micro frontend, and it just works on all the platforms. So that's about it. That's the what we're doing here. If you have any questions, feel free to ask. We have about 10-15 minutes, right, Anupam?
Yeah, we can take questions now. You can there are a couple of questions on the chat. You can take them first. People can ask their own directly to you, Akash.
Cool. How do you render native components in React Native infra? Is it a question on React Native part, or is it for Oran? How we do it at Urban Company?
It can be both.
Let's cover both. Yeah. So as we talked about it earlier in the architecture part, to render native components, you just need to expose it over a bridge. Um, let me show that slide again. This part. If you have a custom view, native view, you can just React Native SDK provides with you with a view manager, where you uh, in the view manager you basically implement this function called create view instance, which is called whenever the component is mounted or re-rendered. Uh, okay, just the mount part, and these setter functions update the view properties, and this is actually rendered on the view with the yoga thread that we talked about. They give you the layouting part, all the layout calculations where it's supposed to be what width and height should be accommodated to render this element, and it's rendered by the UI thread. This is how React Native does it. Uh, all the text views and the view groups are all exposed by the React Native SDK, and you can actually even expose your custom view groups to React Native, which can now then wrap multiple views inside it. So you can actually try to expose a linear layout or relative layout directly to React Native if you want. React gives you that flexibility. On Orion, what we do is we try to move all the layouting part to backend because screens are dynamic and we want to build screens as fast as possible, and we might have cases where we want to update certain widgets dynamically. So for that kind of flexibility and to have it all in one place, we send a payload from backend which expects what kind of layout we want. The layout builders that we shared had that. Uh, and then we had this uh, sorry. So this layout builder generally has that kind of information that if this kind of payload is coming to me, then this kind of layouting system needs to be implemented for this page. And the VDL is exposed with a dashboard. So basically anybody can see what kind of elements they want, and they put it in a proper structure in that payload and we build it. Uh, this platform layer is responsible for rendering it. And what it does is it basically hooks in any kind of VDL which is using the interface it expects, and it renders it dynamically given the type of widget. What we need to do for a widget is basically the type of widget and the data to render it. Similarly, for all kind of actions, all kind of interactions, we need the type of action and what data to you need to execute that action. So we saw that pattern there. We standardized it. We created generic interfaces, and that's how RAN came into being. Next question is by Arnav. Can a single activity in Android have multiple React Native views in it via fragments? Do all these native views, React Native views, work in separate JS threads or the same one? So all these native views actually work on the same thread because there's one single JavaScript thread on the native platform. That's a limitation that we have now, which will be solved soon by the React Native community. What you do to implement a React Native activity is the activity or fragment. That React Native SDK gives you a React root view. Uh, to that root view, you just pass it in your bundle and you pass in your instance of React, and then whatever data you give it, you can use it to render the route or the page you want to build, and it does that. It does everything inside that view. So you can have multiple React root views inside your view. You can have it in a bottom sheet or a fragment or a activity, anything. It's just up to you. What is the criteria for deciding whether something needs to be written in native layer or React layer at Urban Company? That's a great question actually. And this is something that comes from a bit of experience that uh, since we know that bridge is a choking part, we don't want to do any kind of heavy lifting on the JS thread. We want most of the heavy things. Heavy things would be something like a native view, something like a video player or a image view. If you have that natively, you have the flexibility to cache it. You have the flexibility to have a single instance powering, for example, the single exoplayer instance powering your video views, which may be multiple on the screen. Um for images also, you have more flexibility when you have it natively. You can always use an open source library. For example, there's fast image, React Native fast image by uh, some group. Uh, but you can take it in your control because you understand your use cases best. Uh, and there are several case studies of different apps that they what they did. For example, there was a music app that used a kind of countdown and a lot of uh, logic used to run on which music to play next. and they moved that all that heavy lifting and all the counters to native, and they saw significant improvement in the performance of the app. So that's what the best thing about React Native is. It's not forcing you to write everything on React or React Native. It gives you the flexibility that you decide what you need to do. Harshit asks the question that, can you tell something about native Java SQL bindings and how they work with React Native? That's a deeper question which might not be covered in this talk, that we can discuss separately. But in simple words, there's this JNI that that understands the C++ code that everything boils down to in the end. Just like there's Android SDK, there's Android NDK, native development kit, which a lot of game companies also use to build their games. It basically gives you flexibility to do anything on using C++ at the deepest level. So what React Native did was, using that, they implemented a lot of functionality, and since it's C++, it also runs in iOS. So they just needed to do this once, and in that thread, they what they're doing now is that they uh, all the native modules that you write, the Java modules, they expose it globally on that environment, on the C++ environment. So that way, when JavaScript wants to invoke some functions, it gets that from that global environment. That C++ is more. Uh, so that's about it. There's a question by Avinash: how React Native is better than Flutter in terms of performance? So as we discussed, since React Native is not forcing you to write everything on React, uh, but since how we saw that bridge is a choking part, and Flutter actually what it does is it, like how we talked before, that React could be implemented natively directly. That how they did for iOS for component kit. They created a library called component kit, which knows what React is, and it renders everything React. So Flutter kind of went something that way, and they actually build whatever code you write in Flutter directly gets executed uh, along. It also gets compiled and executed along with the Java code. So obviously, this gives a head start of Flutter that it's better in performance now, and I don't think it has a cap of any kind of frame limit. So those are performance advantages. But as we discussed, React Native can match that performance because you can choose to implement these views yourself. You can use things like reanimated to perform to have performant animations. And with the new architecture that we saw that Facebook is coming out with this year, uh, you see that how they actually replace that bridge. So their major drawback is now gone. So in the coming few years, we'll see that maybe there would be a like a good competition between Flutter and React Native in terms of performance. Uh, but since the community of React Native is a lot bigger, and there's a learning curve for Flutter that you need to learn that. So there's always pros and cons for both platforms. But yeah, performance Flutter is better now. We might not know in the end of this year.
Wait, I think one got left. That was from. So when you talked about like micro front ends and the developer not knowing about what underlying platform they are writing code for, so I was wondering like how those micro front end code is getting integrated into individual platforms.
Right. So all we need to do is just bundle that, right? When you write a JavaScript code, the platform layer that we talked about, that understands that the platform layer actually exposes some interfaces that you use to write your pages, all the interactions, what needs to be rendered, and how it's what kind of interactions need to be performed. This all is written in the micro frontend. When you build the bundle, you import things from the platform, and platform knows how to render it, how to interact with it.
Okay.
That platform is basically Orion React Native, which we have, which wraps over all the native things. So basically, all that rendering part and all that interaction part is automatically handled. You just need to expose the map, kind of a map of these are the widgets and these are the interactions. And what's needs to be done is basically handled by the platform.
So like when let's take an example, like when Android has to show a screen which is developed in React Native. So that screen is developed in that bundle. Is it already there in that bundle, or like how Android will decide like how to call it?
So that's the part. Instead of like, there were a lot of libraries like React Native navigation that is popularly used to navigate between screens. But what we instead did was that we implemented navigations natively. So for Android to open an Orion page, they need to actually have that context natively. So they need to code it, because Orion does not give you complete control of native. It gives you complete control over React Native as of now. We can obviously standardize this as well. But for now, that's what we are kind of doing. And any kind of navigations from Orion to native or Orion to Orion is basically done with a navigation module that we expose. So that part is inside that bundle, and that part can be dynamically controlled over from backend as well. Backend can say redirect to this page, and that function that is executing natively can fetch that data from backend and then execute it.
Cool. Does anyone else has any other questions? No? In that case, we will be sharing the video on our YouTube channel. Do ask the follow-up questions. And the last slide is by Akash. I guess, Akash, go ahead.
Yeah, so we are hiring obviously at Urban Company, and if you are interested in building this platform with us, shoot your mail at shoot my mail. You can see the open positions at careers@urbancompany.com. Cool.
Okay. In that case, thanks, Akash. Thanks to Barack Obama also. And thanks to everybody who tuned in on a good Saturday. See you soon. Take care. Abhishek, any other parting words?
No, I think yeah. So we'll be doing our next meetup soon, somewhere around 12th March or so. Do try to join that as well. And thank you for tuning in today.
Thanks, guys.
Thank you.
Take care.
Bye.